Okay, we're going to talk some more about wide area networks and the basics of such wide area networks, some terms, and what kind of equipment you'll use. And some of this will be a rehash from the network media and such videos, but there'll be some new stuff here as well. So for wide area networks, what are wide area networks? So WANs, wide area networks, are owned by service providers. So these can be, Verizon, Comcast, AT&T, Sprint, your local company, whoever it is, Cox Internet, all the other ones out there. Whoever it is that the organization that leases a connection to you. The WANs are required to interconnect LANs. So you need a WAN to make your two LANs connect across a large distance. If you have one location in one city and one location in another city, you're going to have to use some sort of wide area network to send traffic from one of those LANs to the other LAN. WANs themselves are a layer 1 and 2 technology. In fact, one of those options I mentioned before is Metro Ethernet, for example, which is becoming more and more popular. It is terminated at your premises in a RJ45 connection. It's a layer 2 connection. It's very simple to manage and uplink to. It's a quite common option for people to use, and it's even beyond metro now. It's the term Metro Ethernet is because it started in metro areas. It's now branched out into larger regions. We have some specific terms related to wide area networks. So we have customer premises equipment, CPE. So your customer premises equipment is equipment that the subscriber owns. Subscriber meaning you, the company that you're part of, whoever leases from the internet provider or the WAN provider. There's the data communications equipment, DCE. So the data communications equipment is owned by the provider. That might be some sort of termination device. Maybe their own, half of like a router or something like that. There's also the data terminal equipment, DTE, which is owned by the subscriber. And that transfers data from your local area network to the DCE so that it can go onto the WAN. Sometimes these are individual devices, sometimes they're built into one, and you lease the whole thing from the provider, or you own your own, or something like that. It depends on your setup. There's also the Demarcation Point, or DMARC, as it's shortened, which is the closest common closet in a building where all phone and data terminations occur. Usually if you're on, I'll just put a common closet. If you're in a single floor of a large office building, and the office building rents out a bunch of different offices in the area, they'll all come back to that one closet on that floor, and then the next floor might have their own, and so on. There might be one for the whole building, and the ISPs have access to that DMARC closet, and then you'll have cables run from your office into the DMARC to connect to the provider's network. There's the local loop, which is also referred to as the last mile. which really is the length of cable that connects to the central office, or CO. And so speaking of central office, the central office, or CO, is that nearby office that's within a few miles of your location, which is the provider's termination point, where it then goes into their backbone fiber network, for example. For technologies such as DSL, which we'll talk about, there are many central offices that are usually very close nearby, a lot of smaller little buildings that are needed to make that functionality work. And another term would be toll network, which many of them are in some fashion. All the equipment, cabling, and so on that's inside a provider's network. Which is then leased out to you for a price, hence the toll. So since we're talking about equipment, I'll blank this out and we'll start fresh with the types of equipment that are out there. There is the dial-up modem. Anyone who was online in the 80s and 90s and even early 2000s are probably quite familiar with the dial-up modem. It's a legacy method of connecting, uses the phone lines, and the term modem refers to the modulation of the data signal across the phone lines to utilize that that original plain old telephone system cabling. We have access server, which is a concentrator for dial-up connections, so part of that legacy network. And going into more recent types of modern connections, you have a broadband modem. Same idea as a dial-up modem, but it just connects to a different type of cable, a different network. So that's used with things such as DSL, cable, fiber, etc. You have the Csu and Dsu. So the Csu offers termination for your signal. And your DSU converts the frames, the line frames, into LAN frames. So this basically converts your data from that one network to the other. There's a WAN switch, which are very powerful, specialized equipment inside a provider's network, used to transfer data throughout their backbone network. And then we have a router. So router is used to provide access through the WAN, through some sort of interface that's compatible with that WAN technology, such as serial connections, for example, which is probably the most famous and most often referenced method. I mentioned previously the differences between switching technologies. So there was a circuit and a packet switching technology. The circuit being the legacy method, which really has gone away. Previously you had connections between locations. These were like different offices that of the provider, and when you tried to connect from one location to another location, you would then open up a connection that was dedicated to you between those 2 points, and whether or not you sent any data, any voice traffic, any data traffic, whatever, that was dedicated to you, and that bandwidth was wasted if you were not transmitting. Whereas a packet network, you have these connections that are already up and running, and when you try to send from one to the other, you have to address your packets with the proper destination, and then those will fit onto that wire to get to its destination, and then other people might be sharing that same wire when you're not transmitting, so you have more efficient use of that bandwidth. And then you also have abilities for failover and load balancing and such that we've gone through with routing. So for technology-wise of what's actually available to you for a WAN connection, there's a bunch of different options. And so some of them, we'll start out with the most legacy kinds and kind of move our way to the newer stuff. So one of those options is a leased line, which is pretty much the oldest technology. It's been around since the 1950s. It's a dedicated line. It's really a legacy method. People refer to other types of connections that we'll go over as leased lines, and I've done it as well. It's just kind of carry over from that that time. If you call up a provider and asked about a leased line, they're probably going to try to sell you something like an MPLS or an ATM or a frame relay, like what we'll talk about in a second. So it's not really used anymore, but it's the term carries on. There's the Pstn, which stands for the Public Switched Telephone Network. So that's also a legacy system from a very many decades ago. This is what, when we refer to dial-up, you're using the Public Switched Telephone Network to send data through a modem across that original network. There's also ISDN, which is also relatively old. Integrated Services Digital Network is what it stands for. And that's a circuit switched method, so that's why I mentioned it's older. You may still need to use this kind of a connection way out in a very rural area, but most likely those are going out and in favor of the newer technologies. It has a very small amount of bandwidth capability compared to what we are used to now, of a maximum of 128 kilobits per second. So not really something you'll be itching to purchase anytime soon, but that is certainly available in some rural areas, I would bet. You have frame relay, which is still pretty popular. And frame relay uses a virtual circuit, VC or PVC, to identify data connections between two locations, and it creates a DELC, a data link connection identifier between two locations. So it's kind of like an IP address, like we've been doing between two hosts. One location will have one DELC and one location will have another DELC, and when you try to send traffic from one location to the other, you send it to that DELC number. So we'll be going into that. It also, with the virtual terminology there, it supports virtual circuits, so it acts like it's a circuit that's dedicated to you, but it is actually on a packet-based backbone. We also have ATM, which is asynchronous transfer mode, and that can transfer any kind of data, which is very flexible. It uses a method called cells to transfer data, and they're very small. They're only 53 bytes. Only 53 bytes in size, so Unfortunately with ATM is it needs 20% more bandwidth. Due to that overhead of those really small those really small cells. So if you were using a larger cell size or a larger frame size, then you'd be able to send more data with less overhead. So ATM was a nice technology, and it's falling out in favor of others such as MPLS, which is probably the most talked about nowadays. Multi-protocol label switching, so it kind of takes over for a lot of the functionality of ATM, and it can carry anything, including ATM itself. So it can carry any traffic, and MPLS can carry ATM, frame relay, anything. That's the whole point of the whole multi-protocol methodology. It'll label those as needed to get across the media. So those are some of the basic options you have that Cisco has in their CCNA. There's other versions and other flavors available out there, but those are the core ones. And those are the kinds that you would lease through some sort of subscriber agreement with a provider. There's also your public options. So I'll try and fit this on here too so we have them all on one page. But the public options are such as DSL, as I mentioned before, which is digital subscriber line. And this combines existing telephone cables into one cable, one virtual cable. And it runs time division multiplexing to make that happen. So you can actually get really fast T3. Remember we were talking about the T carrier and how you keep bundling more and more phone lines, quote phone lines together, and you can get greater and greater speeds by just bundling more and more things. So you can get T3 and up speeds on the Pstn network by using this sort of bundling idea. It also can share the line with voice traffic, and it does so by using a filter. So the data is overlaid on higher frequencies, and the voice traffic for regular telephone use is on lower frequencies. So when you have a DSL set up in a home, for example, you're going to have to go around and put these little filters in place in line with all of the telephones, so that only the voice traffic is heard through the telephone, and the higher frequency data transmissions are sent across the wire, and you don't have to hear them. Probably the most common version of DSL is what's known as ASDL, asynchronous. ADSL, sorry, asynchronous DSL, which means it has a different download speed than upload speed. So that's where you get those things when you go to purchase a connection where it says, it's 15 megabits down. And then usually in small print they'll say something like, and it's 1 megabit up. So your download speed is this much and your upload speed is this much. A lot of times on these sorts of connections, your experienced speed of loading a web page or something like that is not just based upon the server that you're connecting to, but also your upload speed when you get into these really low-end connections. Having a faster upload speed can actually help you a lot of times. There's also cable, which is another huge option for people. It uses the existing coaxial network, and that started in, I believe it was 1946, right after World War II, was the first cable TV network, and those have grown since then. So this uses that coaxial cable we were talking about through long distances, and there's a shared trunk under a street, and everyone taps off that trunk, and then that goes back to a CO and so on. in the early 2000s when cable and DSL were duking it out, one of the big selling points that the DSL providers were trying to give was that you had a direct line to the central office, whereas cable, your neighbors could affect your download speeds potentially. So that was one of the things they were talking about in their marketing material. And cable uses a functionality called DOSIS, Data Over Cable Service Interface Specifications. So if you look at a cable modem, it'll usually say something about having a DOSIS standard supported. There's also fiber, which is becoming more and more popular, such as Google Fiber, which is the new thing in what is that, Kansas City and Austin now and other places. And then Verizon has a huge rollout that they've done throughout many areas, and other providers are also starting to do that as well. So this is usually this is considered a more expensive type of setup, but from what I've seen, the prices are equal to, if not better than, the other kinds of connections that you can purchase, such as DSL and cable, as long as it's available in your area, due to them wanting to get many subscribers on these new lines that they had to put in the ground. So the upfront cost to installing this new fiber network over the past 10 years, they're really trying to fill them up now with as many subscribers as they can, so the pricing is usually not too bad. And also something I would, before we move on, just since I'm talking about these big three here, these are like the big three that you'll see a lot of times people use, and I would say that it would make the most sense if you're in a decently sized business that has the financial backing to purchase a couple internet connections at least. If you can do so, get at least 2 of the 3 types of connections, and then you can use a firewall or router to load balance between the 2, or at least do a failover to the other connection if something goes down. And if you use a different provider, the odds of one going down and the other going down at the same time are reduced, at least. If you can find one that goes over a different local loop, remember that last mile, if fiber comes in off of a different local loop than the cable, then that's a great way of keeping your internet up in case something happens to the local loop. For example, I was working at a place many years ago, actually, not just a couple, and someone put a giant auger through the core local loop just outside the building. So unfortunately in our area we didn't have a second local loop that came off of our office building area, so everything went down. But if you had that option, you would have still been up and running as the augered hole was repaired. So there's 3 other options that you have, which some of them you'll probably have already thought of, such as satellite. So really, satellite is probably your least wanted connection method because it's very expensive and it's usually rather slow. Unless you're in a highly remote area, it's probably not your best option. Probably your best option in a rural area that for some reason doesn't have DSL or something like that would be cellular, actually. The cellular carriers are really pushing still really hard to get the most coverage, and you can use that to your advantage. So you can use 3G and 4G providers. Some of them are specialized, some of them you can go right through the major providers that are out there, and you can connect specialized routers even. For example, in the eastern area where I am, we have a company called Clear, and they provide even like a home router type idea, or like a wireless access point type idea where it interfaces with the cellular network, and they give you a plug basically like a switch, and you can just plug right into that, and now you have 3/4G type speeds out in the middle of nowhere. So that's a nice option. And then regarding all of these kinds of connections, you can run this, which is, I love this, over all of these public options to give you the functionality of all these private wide area network options. You can run a virtual private network, a VPN. You've probably heard that term before at least once. So what you can do is run a VPN over a public network, and while you don't have the sort of quality of service and subscriber agreement that you do with a wide area network that you've leased, it is much, much cheaper. And if you are not in a very large company, it's probably a great option for you to interconnect multiple sites for a very low cost. So you can use a virtual private network to encrypt your traffic from one location to another over the public internet connection options that you have available. So this is a great option for you. And there's many different technologies involved with VPNs. And before I was talking about CCNP security and CCNP wireless and all these different things out there. You can get into that as part of the security side of Cisco as well. So there's many technologies you can learn about. There's IPsec, which is probably the biggest one that's the most used. There's L2TP, there's PPTP, there's a bunch of different options you have out there to run VPN over the public internet. So with that, we will move on to actually talking about and configuring some of the wide area network types, such as point-to-point and HDLC and things like that.